Hi, I'm Walter. With this video I want to show you my little contribution for the war against the coronavirus, the Jetson Fever Control application for Nvidia Jetson Nano 2GB board. The application uses a FLIR Lepton3 module to acquire thermal information and the temperatures that are fused together with the information coming from the Stereolabs ZED2 camera that provides 3D information, so distances, and object detection. In this particular case, I can detect a person and extract the bounding box of the face where the temperature are calculated to check for fever. And if the temperature of a person, of people, is too high, an alarm can be issued. Let's see more of the application. Here, in this little window, you can see the full thermal image, not elaborated. And here you can see all the control to calibrate the two kind of images. Here there is the thermal image fused with the RGB information to display where the temperature is right and where the temperature is not. I added a simple control to simulate for fever. I can add a few degrees on the real temperature just to simulate the warning state. In this case, I added 1.8 Celsius degree to my temperature, and the application sends a warning to say that the temperature is a bit over 37 degrees. That is the threshold for warning, but it is not yet a fever. And if I add a bit more degrees, the temperature rises up to 37.5 Celsius degree. That is a fever temperature. In this case, the application sends an alert, and the correct action can be taken to for this kind of situation. The application measures the temperature of all the people that are present in the room, but displays only the temperature of the nearest person to the camera. This thanks to the information provided by the ZED2 Stereolabs camera, that is a stereo camera that provides 3D information. I can also show you a bit more about how people are detected, because here you can see my skeleton that is extracted automatically thanks to the ZED SDK, that is the software provided with the camera that provides information about all the skeleton of a person, and the position of the nose, the eyes, the ears, that are useful to extract the temperature exactly where it must be extracted, because the temperature is calculated only for the pixel that are inside the bounding box and that are in the range of the human temperature, that is a bit less than 35 degrees and not more than 42 degrees. That is a very big, very high temperature. Okay, as you can see, the Nvidia Jetson Nano 2GB board can handle all the modules, all the operation. In this case, it uses an AI module to extract the position of a person, and the application runs in runtime without slowing down, and the power, the computational power of the board is enough to handle all the tasks required for this kind of operation. So people extraction, skeleton extraction, skeleton tracking, head detection in this case, and the elaboration to calculate the temperature of the person. Now I removed the simulation, you can see that my temperature is normal. I can remove the skeleton, and as you can see, there is no slowing down, even extracting the skeleton or not extracting it. The application also allows to calibrate the position of the thermal image respect to the RGB image. That is straightforward to calibrate. You can see you can move it up and down, left and right, and you can also, just a moment here, and you can also scale it to match the right position according to the RGB image. Okay, that's it. Now I can remove the calibration, and this is the simple guide providing all the useful information for this kind of operation. Here on the right side you can see a great tool, a very useful tool, that is the Github, the Jetson created by my friend Raffaele Bonghi, where you can see all the performance of all the hardware of the Jetson Nano board. As you can see here, the RAM used, the memory used for the operation for the application is less than 2 gigabytes, so the Jetson Nano can handle without any issue this kind of tasks. And there is a swap file enabled, and not of 4 gigabytes, and not all the sites of the swap file is used. Here you can see that the 4 cores of the Jetson Nano are used a little bit lower than 90%, and here you can see how the GPU is used, because the deep learning, the AI module of the Z SDK requires a lot of operation, a lot of resources to extract the skeleton, to track the body, to track all the position of the code. And this is everything else. So thank you for watching. Bye.